Welcome to the video on solving radicals part 2. In this video we're going to solve some radical equations that may require you to square both sides of the equation more than once in order to solve the equation. We'll also learn how to use our graphing calculators to solve radical equations. Let's look at example 1 where we have the square root of x plus 5 equal to 5 minus the square root of x. I'm going to write down some steps that I'm taking because you're going to follow some similar steps more than likely when you're solving problems like this on your own. The first step is always to isolate the radical, the same way we did in part 1. So we're going to isolate a radical. It's really your choice which radical you isolate. And in this example, I already have a radical isolated on the left side of the equation. It's the square root of x plus 5. I wouldn't want to go through the extra work of isolating this guy because I already have the radical x plus 5 by itself. So step 1 in this example is already done. Step 2 is to square both sides to undo the radical. Alright, so in this example, if we square both sides, I would have to square the square root of x plus 5, which the whole idea is to undo that square root, and it does, and I just get x plus 5. On this side, you cannot just simply distribute that exponent of 2 to the 5 and the negative x. What you have to do is rewrite the binomial 5 minus the root of x twice, and you have to multiply that out. So if we multiply that out, we're going to end up with 5 times 5, which is 25, 5 times negative root x, which is negative 5 root x, and then another negative 5 root x, and then negative root x times negative root x is really positive x. So remember, the square root of x times the square root of x is the same as the square root of x squared, which is just x. So this is where we're at on the right side. On the left side, we still just have x plus 5 kind of sitting there waiting for action to happen to it. Let's add up these like terms. Remember, these are like terms. They have the same base and the same radical. So I really have 25 minus 10 square roots of x, if you add the coefficients, plus x on this side equal to x plus 5. So we've just squared both sides. And notice, this is a little different than the other examples because we still have a radical in our equation. So we have to kind of do the same step again. I'm going to have to go back to step 1 and isolate the radical again. So really my third step is to isolate the radical again. So if I do that, that means I'm going to have to subtract 25 from both sides and subtract an x. Let's just do both at the same time. I'm going to subtract the x and subtract 25. Now doing that, I get x minus x to cancel. That's kind of nice. And I get 5 minus the 25 is a negative 20. And then these cancel and these cancel. And I have that equal to the negative 10 times the square root of x. If we divide by negative 10, we'll have successfully isolated the radical. So I'll have 2 equals the square root of x. The last step is to, once again, square both sides, right? If we square both sides, we end up with x on the right, and when you square 2, you get 4. Now, just like before, you want to check your solutions because it might be that it's extraneous. If we plug in 4 for x in the original problem always, right, we're going to have the square root of 4 plus 5 equals 5 minus the square root of 4. Well, the square root of 4 plus 5 is the square root of 9. And this side is going to be 5 minus 2. So I get 3 equals 3. And we've just verified that 4 is the solution. What we're going to talk about right now is another way of solving the same problem, but let's use our graphing calculator. When you use your graphing calculator to solve this, we're going to start off with the same problem, square root of x plus 5. And it was equal to 5 minus the square root of x. But the whole idea here is, guys, we're going to let one side of the equation be our y1 and the other side of the equation be y2. And what we're going to try to do in our calculator is to try to figure out when does y1 equals y2 or equal y2. Now, guys, graphically, now I don't know what these look like, but when we solve graphically, just like when we had systems of equations, if you had a line here and a line here, the solution is where they cross, that coordinate. Okay, so we're going to do something similar and try to find the intersection of y1 and y2, and I'll show you how that will give us the same answer of x equals 4 in our graphing calculator. So I'm going to write down all the steps first, then I'll bring up my calculator on the screen, and we'll verify that we got it right. So when you solve by a graphing calculator, so by graphing, your first thing is to let y1 equal the left side of the equation, which in this problem is x plus 5, and let's let y2 be 5 minus the square root of x. Then what we're going to do, after we have that in our calculator, step 2 is to graph both y1 and y2 together in a window that shows the intersection. So that's key. You have to see the intersection. If you don't see like where the lines cross, you're not going to be able to find the solution. And maybe if you're lucky, you'll get it in the standard window, but you may not be. After you do that, we're going to hit the zoom I take that back. You don't want to hit zoom. We're going to get to that calculate menu, which is not zoom, it's second trace, right? We're going to hit second plus the trace button, trace, which is the calculate menu. And you're going to choose, I think that's number 5. You're going to choose number 5, which is intersection. And then all you're going to have to do, really, from there for step 4, is hit enter 3 times. And you'll see when we do that on the calculator in a moment, when you get your final coordinate, you're going to get like an x value and a y value. That y value really has to do with the output for the x. Really, your solution is that x value. So let's actually try this on our graphing calculator now. Okay, so if you have your calculator, let's turn it on and go to y equals, and then remember for y equals we're going to do the square root of, it was x minus 5. Make sure you have this in parentheses if you have the calculator. It doesn't actually show it as the radicand. And then the other one was 5 minus the square root of x. Okay, so this is what you should have for y1 and y2. We're going to try to go in the standard window. I'm going to go to zoom 6 and see if we can see the intersection in the standard window. Now, you could see I have one curve it looks like 2 curves that hit almost on the same screen. I'm going to adjust my window because it looks like the intersection is not quite where I'd like it. I can't quite see it. It might be somewhere over here, so I'm going to adjust my x max, right? Let's make the x max go a little bit further on our screen. So if I go to the window, I'm going to change my x max to, let's say, 20, and then we should see it a little bit. Oh, there we go. So now I can see very clearly where they intersect. Now what I do is I hit second and trace to get to the calculate menu, and I want to find the intersection of those 2 lines. So I'm going to choose the 5th option, intersect. And if you hit enter there, it's going to ask you for the first curve, second curve, and guess. You really could just hit enter, and the guess, you don't have to move it next to the intersection unless there was more than one intersection. In this case, there's only one intersection. I could just hit enter again, and it tells me the intersection is at 9 and 2. Now that's interesting because we saw that the solution was really 4. So it makes me think something is wrong here. I bet I made a mistake with this. I have the square root of x minus 5, and it was really x plus 5, wasn't it? Well, there's your mistake. I'm glad we caught it. Let's try this again. Let's go to zoom 6. Ah, it's slightly different. So now let's practice it again. I go to second trace. If we choose intersect, I hit first curve once, second curve, hit enter again, guess, hit enter a third time. Now the intersection's at 4, 3. And remember what I was saying before. When you get your intersection, this coordinate, remember, this is really 4, 3. That is this x value is our solution. So I know that x equals 4 is our answer. Okay? And we've just verified it. Let's do another example. In this example, let's solve when the square root of 3x minus 2 equals 1 plus the square root of 2x minus 3. Again, I'm going to follow those same steps. I want to isolate one of the radicals, and I notice that this guy's already by itself, so I can undo that radical if I simply square this side, but if I square that side, I have to square this side. If I square the left side, I get just 3x minus 2, which is nice. On this side, this is going to be a little ugly at first. I'm going to have 1 plus the square root of 2x minus 3, and I have to write that out twice, remember, because I have to multiply that out. I have to FOIL that out. Now, this is where you have to be kind of disciplined and not make any mistakes. The left side's done, it's easy, but when I multiply this side, 1 times 1 becomes 1. Then I'm going to have 1 times the square root of 2x minus 3, so that's going to be just the square root of 2x minus 3. If you multiply the square root of 2x minus 3 times 1, you get another positive square root of 2x minus 3. Then the square root of 2x minus 3 times the square root of 2x minus 3 really is just going to be positive 2x minus 3. Again, remember, if you multiply a square root, 2x minus 3, times the same square root of 2x minus 3, you really have the square root of 2x minus 3 squared, and these undo these radicals. So you just get 2x minus 3, and that's a little tricky. Here, I'm going to add the like terms. These are both like radicals. So this side is 1 plus 2 times 2x minus 3 in the square root plus 2x minus 3 on the outside there, and I get 3x minus 2. Now what I'm going to do is try to add up some like terms. I have a 1 and a negative 3. That's really a negative 2. And then I have the 2x, so plus 2x plus 2 square roots of 2x minus 3 equal to 3x minus 2. Well, from here, we still have a radical. I'm going to get that radical by itself by adding 2 to both sides and subtracting 2x. So I'm going to minus 2x, and if I do that, 3x minus 2x is x. These cancel, and these cancel, and I get x equals 2 times the square root of 2x minus 3. It's almost by itself. I have to divide both sides by 2, and if I do, I get x over 2 equals the square root of 2x minus 3. Now it's isolated, the radical. We're going to square to undo it, and I got to square this side. If I square a fraction, I got to square the top and the bottom. So I'm going to have x squared over 4 over here, and on this side, I just have 2x minus 3. Now, in order to get rid of this fraction, I don't want to have x squared over 4. Let's multiply both sides by 4 so that these cancel, and I now have x squared equals, if I distribute, 8x minus 12. I have a quadratic equation now that I can solve if I just subtract 8x and add 12 to both sides, giving me x squared minus 8x plus 12 equal to 0. These all cancel. I hope we can factor this, otherwise this is a really tough problem, and I think we can. I think that factors into x minus, 6, and an x minus a 2, because these multiply to make 12, and they add to make negative 8. So I have two solutions apparently. X is 6 and x is 2. By the way, what we just accomplished is probably one of the tougher problems you have seen, not only in the chapter, but maybe in your math careers. It's kind of a tricky one. Lots of places for you to make mistakes. But don't celebrate quite yet. We have to make sure that neither one of these is extraneous. So if I check back into the original, x equals 6, in the original I'll get the square root of 3 times 6 minus 2, and that's supposed to be equal to 1 plus the square root of 2 times 6 minus 3. This is going to be 18 minus 2, that's the square root of 16. Over here, I get 1 plus 2 times 6 is 12 minus 3, I get the square root of 9. This is going to be 4 equals 1 plus 3. Hey, we get 4 equals 4. I'm in shape with x equals 6. However, I don't know about this next guy, x equals 2. If we plug in 2 and check it, we're going to get the square root of 3 times 2 minus 2 should be equal to 1 plus the square root of 2 times 2 minus 3. So I get the square root of 6 minus 2, that's 4 on that side. And I get 1 plus 2 times 2 is 4, and 4 minus 3 is 1. I get the square root of 1. So I get square root of 4 is 2. 1 plus the square root of 1 is 1 plus 1. Hey, we get 2 equals 2. Good news. Both of these are solutions, and we've just verified it. We've checked it. I would like to show you next how we can use our calculator once again to verify both of those solutions. Now what I'd like to do is finish this. Let's check it into our graphing calculator. So we're going to go to the graphing calculator and we're going to type in, remember the left side is going to be our y1. So I'm going to clear out the old problem, and this time let's see if I can type in y1 actually correctly. Recall y1 should be the left side of the equation. In this problem it was the square root. So we're going to do square root of 3x minus 2, 3x minus 2. Make sure we close that off in parentheses. Our y2 is the right hand side of the equation, which was 1 plus the square root of 2x minus 3. So we're going to put 2x minus a 3 and close off the parentheses there. I'm going to go to zoom 6 and I'm going to hope we can see it intersect in our standard window. And right now I really don't see anything. So we're going to go ahead and make sure we can, let's zoom out a little bit. I'm going to zoom out, well, make sure I have, yeah, they're both in there. We're going to go to zoom out, and let's zoom out from, I'm going to move my cursors over a little bit, my crosshairs. Let's zoom out from here. Oh, this is interesting. They're so close to one another. It's actually, we got to zoom in. Let's zoom in. This is a tough one to do by graphing calculator. Actually, let's go to zoom 6 again and try to get this back into a relatively, it's really hard to tell, but those are really close to each other. I'm going to zoom box around them. So I'm going to hit enter and drag a window from the origin all the way kind of around this area here and just zoom in only on this part. Not very easy to tell that there's two, man, they're still pretty close together. I picked a really tricky one. This would be like an extra credit one. I hope you guys don't freak out too much. These intersections are super hard to see, but it's kind of a good problem, because if you could do this one, then the ones where it's very obvious where they intersect are going to be much, much easier. So I'm going to drag a window around only this part. I think they intersect right around there. Let's see. There we go. Now I can see where they intersect. I'm going to hit second, trace, and hit number 5, right? And I hit enter 3 times. There's one of the solutions. It says 2, 2. Now remember, when we do this, the x value, right? That x value is the solution. So I know one is x equals 2. To get the other one, we'd have to zoom out and get to the other solution. So, geez, this one was a really tough one, guys. If I zoom out, let's zoom out a little bit, and then I'm going to zoom kind of back in, or zoom box on the other intersection, which it's not clear from the picture that they intersect again. But let's start here and make a box around this next part. And I'm going to zoom in, and hopefully we'll see that second intersection. Now it kind of helps that we solved this ahead of time, and we knew there was another intersection here. Really hard to see that those lines cross, but let's do second, trace, choose 5. We're going to hit enter 1, 2, 3 times, and there's that second intersection. So yay, finally we get to this x value is 6. Remember that was we had the two solutions. There was x equals 6, and we also got x equals 2. So just another way of doing it. Thanks for watching, guys.